In this video, I will show you how to save and load a trained neural network. Saving a fully functional model is very useful. You can deploy your model in web browsers, or you can convert your models to run on mobile device. Furthermore, you do not need the model's Python code for inference. In addition, you can also resume training at where you left. Let's go ahead and see how we can save and load a trained neural network. In TensorFlow, Keras model can be saved completely to a single file. It will include the model's architecture and configurations, the model's weight, and the model's compile functions, and also the model's optimizers. There are two formats that we can use to save the entire models to make sure that your trained neural network is fully functioned. And the two ways are the TensorFlow saved model format, and the other one is a Keras H5 format. The saved model is always the recommended format because this is so much more comprehensive that saves the model's architectures, weight, and also the traced TensorFlow subgraph of all the callable functions. This will enable the Keras to restore both built-in layers as well as the custom objects. There are two APIs that we can use to save the models. That is the models.save or the TF Keras models.save models. Both functions can be used to save the models. And by default, the API saves the models in the saved model format when you are using the model save. In that case, to switch to the older one, Keras H5 format, you can just pass a save format equals to H5, or passing a file name that ends with .h5. Then it will enable you to switch it to Keras H5 format. Let's take a look on the examples to see how we can use these two methods to save and load the model. First thing first, let's just import the libraries that we need to use, and then we set up the input data and output data and by random functions, and we set up the we use the sequential models methods to do so. We just add a first layer and then add the second layer, and then we compile the functions, and then we fit it to the network. Let me run this 2-cell. Now the training has been just completed. Now we can use the model.save to create a folder named my models, and save the model in a saved model format. This is very simple. Just use the model.save functions and then assign the folder name. Now if I run the cell, and you can see the model has been saved. These model.save functions will create two folders and one file. So if I click into my model folder, you can see that there are two folders and one file has been created. The first one is the exec folder, which stores the arbitrary files called the execs that are needed for TensorFlow graph. And then it will store the second folder is the variables, which will store the weights for your models. And finally, we have the saved models.pb, which stores the model architecture, the training configurations, including the optimizer, losses, and also the metrics. So these three files will contain the entire models of your neural network. Let me also print you out to see what are the files that are contained in my model. Here you can see, just like what I mentioned before, we have two folders. One is the assets and the other one is the variables. And then we have one file that is the saved models.pb. Once the model is saved, now we can load the models. We can use the load model functions, which is used to reconstruct the models identically. Now we can import these load model functions, and then we can just simply use these load model functions and put the folder names, the folders that we just create in these .save functions. And then it will load and then these load functions will load these two folders and one files to reconstruct the models identically. Now let's run this cell, and we will assign the reconstructed models equals to this load models function. The reconstructions model is already compiled and have retained the weights, the model architectures, and also the training configurations. So training can resume. Now we can just use the fit functions to continue the training. Let's say if I run this cell, it will restart the training. Now let's take a look on the second method. Instead of use the save models format, let's take a look to see how we can use the .h5 format that is supported by the Keras to see how we can save the models. Similarly, we can just import the libraries, and then we can create the input and output and set up the configuration, set up the sequential models, add two layers, and then compiles the models and also fits the model. Now let me run it. And Keras provides saving a single HDF5 files, which is a pretty much lighter versions compared to the saved model format. However, there are some functions, there are some things that has not been saved with these HDF5 files. We will talk about that later on. And now the model can save by specs. We can still use the same functions that we use, but when we specify it's the .h5 files, then it will use the second way. This is let me show you. It will use the second way to save the models instead of use the saved model format. It will just switch to Keras H5 format to save the model. So we can just simply specify .h5 names into it. It will create that. It will just switch to the other ways to set that up. Now, if I run this cell, it will just save the models that will contain the model's architecture, the weights, and also the compile informations. Let me show you what we got here. You can see because it is relatively lighter in weight, everything is just saved inside this .h5 file. And similar to the saved model format, once the model is saved, load models can be used to reconstruct the model identically. We just need to import the load models and then use the load model functions and then specifies the same names that we save, just like this one. Just make sure the name is are the same, and then the reconstructed models is ready for it's already compiled, and also retained the training model architecture and training configurations. And then we can again use the .fit functions to resume the training. Compared to the saved model formats, there are two things that do not get included in the H5 formats. They include the external losses and metrics, and also the computational graph of the custom object. Therefore, saved models format is always a preferred way to use for save and load the TensorFlow model. In this video, we have just gone through two formats for saving and loading a trained neural network. In the next video, we'll dive into the compile functions and show you how to set up the functions appropriately. See you in the next video. Bye-bye.